Okay, in this video we're going to talk about how to solve a quadratic equation, and most of the time we can either factor it, but sometimes you can't factor it, and therefore we need to use the quadratic formula. You may remember this from Algebra 1. It's a very long formula. We'll get to it in a second, but first let's just practicing reducing fractions. When you have a fraction that looks like this, all you're going to do is really just break it up into two separate pieces. So it's going to be negative 6 over 2 plus or minus 18 over 2. Simplify the fraction, so negative 6 over 2 would be 3, plus or minus 18 over 2 is 9. Now, if you have all real number solutions like this, you need to keep going with the formula, and you would do 3 plus 9 for 12, or 3 minus 9, which is negative 6. So both of these would be the solution to this fraction. The next one, you might get a fraction, that's okay. Negative 5 halves. Again, I'm breaking this up, and then I'm breaking this up. 20 divided by 2, so plus or minus. 20 divided by 2 is 10. 5 divided by 2 is negative 2.5. So negative 2.5 plus or minus 10. One of your answers, negative 2.5 plus 10, would be positive 7.5. The other answer would be negative 2.5 minus 10, which is negative 12.5. So both of these are the answers to simplifying this fraction. Go ahead and try the other two. Actually, let me do this one with you because you have to factor this. When you have the square root of a negative radical, we're going to factor this into square root of negative 4 times the square root of positive 5. This would become 2i, and this would become root 5. It would stay root 5. So now I'm looking at a problem where it's 4 plus or minus this answer over 4. When you have an imaginary number, you do not need to simplify this to get one single number, but you do need to simplify the fraction. Here's what I mean. Take 4 and simplify this way, so you would get 1 plus or minus, and now simplify this. You can only simplify the real numbers, the whole numbers. So 2 over 4 is 1, so 1i root 5 over 2. 2 over 4 became 1 over 2. 1 over 2 is right here. There's a 1 here, we just don't write 1i. Go ahead and try this one. You should get this far, and then all you're going to do is, again, simplify this way. So this would be negative 4 plus or minus. Now 3 over 2 will not simplify, so you just leave it as 3i root 3 over 2. I know this answer looks very complicated, but it is the correct answer. You are still technically going to have two answers because you would do 4 plus all of this and then 4 minus all of this. Since it's imaginary, I don't know what the actual number is, so I just express it like this. With the other ones on top, these were real numbers, which means you could combine this, and you also could combine if you subtracted it. Numbers 5 and 6 are very similar. The only thing you have to do first is actually simplify this and combine all of your like terms. So go ahead and do that. Do not take the square root. Just put exactly what you see in your calculator. You should get negative 5. Okay? Over 4. The only thing you can factor out of negative 5 is negative 1 with positive 5. The square root of negative 1 is I, so this becomes I root 5. So you're left with negative 9 plus or minus I root 5 over 4. If you cannot simplify either of these terms, then just leave the entire thing in this fraction. 9 cannot divide by 4, 1 cannot divide by 4. Go ahead and do the next one. Just simplify what's in the square root, put it in your calculator exactly as you see it. okay? Now, you should get 0. The square root of 0 is 0. So you're looking at negative 9 plus or minus 0, which is still negative 9, over 4. In this case, this is the only solution, because if you add 0 or take away 0, you will get the same number. So it has to be negative 9 over 4. It's okay to have one number as your solution, okay? So far, we've solved quadratics mostly by factoring. We've also used the AC method. And there's another one that we haven't talked about yet, so I'm just going to put here that it's to be determined. It's called completing the square. We haven't gotten to it yet. The last method we're going to look at is solving it by using this equation. It's the quadratic formula. All you have to do is identify the A, B, and C terms, substitute them into the formula, and you'll get your answer. Now, when you do this, you'll be able to tell right away how many answers you will get. So this in here is called the discriminant. If this equals 0, like it did up here, you will only get one real solution. If it's a negative number in here, you will get two answers, but they will both be complex. They will be non-real. So a negative number would give you two non-real solutions, and a positive number, you could take the square root and get two real numbers. So keep this chart handy. This will tell you how many answers you should get and whether or not you're correct or not. Okay, so look at the back. All I'm going to do right now is identify that this is A, B. I need to move this over because the entire thing needs to be set equal to 0, so this would be x squared plus x minus 12 equals 0. So now my A term is 1, 1, and my C term is negative 12. Here's the formula. I'm just going to take my numbers and substitute them in. So negative B would be negative 1 plus or minus the square root of B is 1 squared minus 4 A times C. Okay, go ahead, simplify all of this first. This should be 1. 2 times 1. Simplify all of this first. So you're going to get negative 1 plus or minus the square root of. Let's go ahead and simplify this. You get 49 over 2a, which is 1. You can take the square root of 49. It is positive, so it's just negative 1 plus or minus 7. Remember, every square root has two answers, so there it is, plus or minus 7 over 1. Anything over 1 is just itself, so really I'm just going to take this and do it. Negative 1 plus 7, negative 1 minus 7. One of the solutions would be 6. The other solution would be negative 8. Oh, my fault. Hold on. Go back. This should have been 2a's, which was 2, so we actually should have divided this by 2 at the end. Divide this by 2 and divide this by 2. This would be 3, and this would be negative 4. Sorry, I knew something was not right. I knew that these were not the correct answers because I could have just went in here and originally factored this into x plus 4 and x minus 3. And I would have gotten that x equals negative 4 or x equals positive 3. That's how I knew that this had to be the right answers. So make sure you do 2 times that number. So it was 2 times 1 divided by 2. The next one, again, move this negative 3 over. Here's all of your terms. This is A, B, C. Make sure you take the sign with you. The opposite of negative 8 is positive 8, plus or minus the square root of go ahead and simplify this to get the discriminant. You get negative 68 over 10. Okay, the first thing we're going to have to do now, this is just like the front, figure out what factor that's a perfect square will go into 68. It is 4, so this would be root negative 4 times root 17. Okay, so 8 plus or minus, the square root of negative 4 is 2i. I cannot take the square root of 17, and it's all over 10. You can simplify all of these fractions by dividing by 2. So 8 divided by 10 would be simplified to, divide these both by 2, 4 fifths plus or minus 2 over 10 is 1, so 1i, root 17 over 5. Okay, go ahead and try these. The only one I'm going to stop you at is number 6.